the multi-agent orchestration expert. This is Sahar, our data and scenarios discovery expert. This is Arian, the DGX Spark expert. This is Daniel, our full stack and device integration expert.
This is Mehrazin, the tech lead and the coordinator of the project. Mehrazin from Team Guardian. We built Guardian, a local first multi-agent home emergency AI companion for people who live alone. The core idea is simple. Not every care moment should become an emergency, but real emergencies cannot wait. Guardian receives signals from a watch, classifies the severity routes to exactly one specialized agent, calls reusable tools, and responds by voice. In our demo, Matthew has a nightmare fall with abnormal rhythm and no response. Guardian escalates to a tier 4 safety workflow. On the other hand, Sarah is different. She is isolated at home for several days, but this should not trigger panic. Guardian routes to the companion agent, helps with medication and accessible activity, transport, calendar, and a light family update. Let's look at the live demo. First, we're gonna talk about Matthew. All right, here we have Matthew, and right now we can see that he's asleep, and you can see the phone app that has all the important features, and you can see that in the phone app we can add different features. Right now it shows that Matthew is in the resting state. We also have a backend that provides a live monitoring of the vitals of him. We also have different screening tools to show how the agent works. Now, once something starts happening, you can see that the agents start logging everything. Right now, if we look at the phone, we can see that Matthew is up, and then suddenly his rhythm starts changing, and then we can see that something is irregular, and then Matthew falls, and then no response is detected, and it starts calling 911, and then Sophie, which is Matthew's caregiver, is on the way. And the Guardian also starts reassuring Matthew that he's not alone. And we can also see the backend engine as well, that you can see that we have a Guardian router that, based on the pattern that it's seeing based on the watch, it activates a safety agent, and then that agent activates a particular tools, and then it calls 911, and then you can also see the messages that the agent is sending. Now let's consider Sarah. Sarah is someone that has been alone at home for 6 days, and the Guardian detects that. We can see her profile. She's not doing well, she's a bit depressed, and she is disabled. Now the Guardian sees that and says that, "Good morning, Sarah, how are you feeling?" And then, since she hasn't been out for a while, and the Guardian already knows that she's into painting, based on the public Toronto datasets, she figures out what are the available services, books them, and lets Sarah to attend to those. And we can also see the same thing in the live demo of the backend. So we can see that the companion is activated based on the schedule of the Sarah and Mark met and the history, and also based on the Toronto public dataset, it schedules a particular class for her, and then it starts working. Now going back, okay, now going to the architecture. The architecture is totally event driven, and as we can see, it inputs arrived from watch and voice pipeline, including faster whisper for STT, and every signal becomes an event. The important design choice is a separation of responsibility. The classifier determines what's going on. Now let's look at the stack. The stack is a combination of STT faster whisper, backend fast API line graph, and the LLMs that we are running directly in an optimal way on DGS Spark are listed here, and we are using NVIDIA's specific quantization and a specific device for serving LLMs. Now, we tested with a couple of devices, and this one is the best. Now, Guardian is not just a chatbot for older adults, it's a local safety loop. Classifies risk, selects the right specialization, uses the right tools, and it speaks with right intensity. Thank you for your attention.
This application includes so many different scenarios that can work in principle, but now let's see a specific example of how that works in the system. You have the watch on your wrist and it's sending data in real time to the server, including your heart rate and accelerometer, which detects the g-force. And let's see an example that your heart rate goes higher. Then the system risk gets larger and larger, and at the same time the accelerometer detects high force in the g direction, and then in that case it detects a fall. At that point it asks you, are you doing okay or not? If you answer the system that you need help, or if you don't answer it in the time period, then it asks you, are you doing okay? And for that, the text gets changed to speak via Kokoro and sends back to the watch, and then it looks for your answer. If you don't answer, or if you answer that you need help, then it calls someone that is very close to you and let them know that you're in trouble. So they, or maybe 911, can come and help you with your problem. And yeah, that's it.